Welcome to everyone. I am Shivan Pratap Singh and I am doing my master degree in software engineering from Thapar University. And this is my dissertation. The topic is genetic algorithm with mixed crossover approach for traveling salesman problem. For this dissertation, I have taken a supervisor named Prashant Singh Rana, who is a assistant professor in computer science department. So we begin with our topic. First, we are going to see the problem statement of this topic we are going to explore, and which is we are going to apply this study of genetic algorithm on traveling salesman problem with the different combination of crossover and mutation operator. So, genetic algorithm, you can see this term genetic is a biological term and is related to the natural process we do in our daily life. Like two people meet, fall in love, consummate, and produce a child. This whole soul concept is adapted by a computer science department and named as genetic algorithm. And according to the Darwin theory of evolution, it is said that the natural process of evolution always, or not always, but almost you can say a 90% chances that it produce a better result or better child in every process. That's why we always say the next generation is always better than the current generation. So we are going to apply this algorithm. So before we go any deeper, we have to discuss the different phases of this algorithm. But we are going to do that in the later phase. But we go with the two main phases like the crossover operators and the mutation operators. So in order to talk about those operators, we have to build a ground on which we are going to talk. So what we did here is we created a matrix, a 10 cross 10 matrix, which we called as a random generated population, right? In each matrix, in, in this matrix, each rows is called as a chromosome. Remember this term because we are going to use this term a lot in this lecture. So each rows is chromosome and each column is a gene, right? Now what we are going to do is this is you can see this is a crossover operators. There are numerous crossover operators like cyclic crossover operators, ordered crossover, partially mapped crossover, one point crossover, and the 2 point crossover. There are many more, but we have chosen to talk about only these five, right? Because we are going to just explain a logic, not the whole process. So we begin with crossover operators. So in order to perform a crossover operators, you have to choose two random parents from the matrix or random generated population, and each chromosome we randomly choose any two chromosome and call them as parent. And for able to perform this cyclic crossover logic on those, we are going to put these values in another array so that the original values are not changed in order for later reference, right? Now we have put these values in new arrays. So what we are going to do is this: suppose there are two arrays a and b. What we're going to randomly choose any index uh, of a child b and named as I current, right? And we are going to store this I current in say I 0 in order to reference in the later case, and then we are going to choose any random index in child A. So there is a very rare possibility that both the indexes are same. Even though it is not same, we are going to proceed with the logic like if they are not same, what we are going to do, we move I current to the index of I next in B, so that both I current and I next are at the same position, and we perform this operation till I current is again equal to I0. I0 is the value, initial value that I current had attained at the earlier phase. This is the cyclic. Same you can refer to a net or different paper in order to get other knowledge on other crossover like ordered, partially mapped, 1 point and 2 point crossover. Same is with the rotation operator. There are many, but we have chosen to explain is four: flip bit, boundary, non-uniform, and a uniform one. See, you can see this. This is a basic genetic algorithm. In this, firstly, we initialize the population, select two parents, then we perform crossover and mutation operator in order to create a child. Then we check the fitness value of this child and we compare it with parent. If it's have the better fitness value, we insert it into the population. Otherwise, we insert the parent back, and we do this criteria again and again unless our generation is allowed. Number of generation is allowed. You can say this is the modified genetic algorithm that we have created. We thought we did the same process and changed the only single step in this whole algorithm, like initialize the population, select the parent, same. But here we what we did is, suppose we created two arrays. In one array we put all the crossover logic, like index of the crossover logic, like at 1 is because in MATLAB we have the initial point is 1 not 0. So at 1 we put cyclic crossover, at 2 partially mapped, at 3 ordered, same, right? And same we do it with mutation operator, and this random will generate 1 comma 4, a number between 1 and 4, and this value is put in n, and according to this n we are going to choose which crossover and which mutation operator we are going to apply on a child. After that, when the child is generated, we will check the fitness value of that child and compare it with our parent. If it's better, we insert into the population. If not, we won't, and we will repeat this process until our number of generation is allowed, right? And after we have performed this operation, we find out that the fitness value we have found is better than any value that I have ever seen till now. Similarly, we have implemented different crossover and mutation function in MATLAB, and according to the fitness value, we have determined which LEDs are the best. And after that, we have recorded the resultant one. Thank you.